Hello and welcome to Australia in Space TV. My name's Chris Cubbage. I'm the editor with My Security Media. This is an official lead-up interview with one of our speakers to the Indo-Pacific Space and Earth Conference, 26th to the 28th of November, being held at Crown Perth. Andrey Lopantsev, a Chief Strategy Officer with Asteroid Mining Corporation, going to be part of the sessions on the economics of space mining versus terrestrial mining, a comparative analysis. Andrey, thanks very much for joining us.
Hey, Chris. Great to be here.
Now, Asteroid Mining Corporation, it's a very cool sort of body of work that you guys are doing there. And you're founded in 2016. So you've been going for a while now. Mitch Hunter Scullion was the founder. You're the Chief Strategy Officer. And so maybe introduce us to the actual company and what your current operations are. And then we'll cover you off on your role in terms of Chief Strategy Officer.
Yeah. Absolutely. So, as you mentioned, we were founded back in 2016 by Mitch, my dear friend and colleague. We were founded with exactly what it says on the tin. We want to mine asteroids. That's the end goal. And we've gone about that now I've been with the company 5.5 years. We initially started off trying to essentially prospect for asteroids, find where they are, get a little satellite up, basically get a telescope to find where they are, and then hope that someone would give us money to get there. And then we quickly realized that there's absolutely no money in prospecting data for asteroids if you're still going to need another fair chunk of cash to go and test it, and then another probably a couple of billion to actually get it and bring it back. So right now we kind of reevaluated things and are primarily a robotics company. We build spider robots for space.
Okay, so they're designed to land on an asteroid or the like, and then mine for there. And there has been some discussions around mining in space for space, rather than having that idea of actually bringing it back to Earth. I suppose maybe describe some of your actual operations that you're actually doing now, and in terms of, and even the design of the robots themselves. Are you finding you've got some on Earth new capability or creating new learning for robotics here on Earth?
Yeah, so I guess that's a multi-part question there. So let me give a slightly multi-part answer. In terms of what we're doing with the robots, asteroids can be quite big, but even a big one, like something 2 kilometers across, the gravity is negligible. So if you want to use something like, for example, one of the Mars rovers, if you plonked it on there and started spinning the wheels, it would just take off and keep on going. So if you want to move around on there and actually do operations on the surface, you need something that can stick to the surface, essentially rock climb over it. And that's what we've built. We've built a rock climbing robot. It has some applications on Earth. And one of the reasons we started doing robotics rather than, for example, remote prospecting is that you can actually commercialize them on Earth. Naturally, asteroid mining is not something that will happen within 3 years or within 5. So if you want to stay alive as a company, you need to make money in the meantime. Now, in terms of the actual what's on an asteroid and what's it good for, well, right now, we're going through an energy transition. As we move away from fossil fuels, there is a number of technologies coming up, both in terms of battery storage, renewables, hydrogen, and all of these require supplies of critical materials and critical metals that at the moment are not running out is the wrong term for it, but finding new sources of them often means going into greenfield sites and digging them out. For example, Antarctica, it's limited by treaty, but there's a lot of people looking at it like there's probably a lot of resources there. The other big one that's been in the news is deep sea mining, where essentially strip mining the seabed and ecosystems we just don't really know anything about in order to get these metals. So it's a bit of a trade-off. Do we keep burning fossil fuels and emitting carbon, or do we get these metals in ways that are potentially damaging to the environment? I see this as a third alternative, which is the ability to get metals where there is no biosphere, there's nothing to damage, there's nothing to pollute, and bring them back and then feed them into this decarbonization process.
I think, and you're right with my multi-pronged questions. I tend to do that in terms of thinking aloud, in terms of what is of interest. One question I had, and there is a roadmap on your website that we'll have a link to, but how accessible and how many of these asteroids are available? Obviously there's millions of them, but how accessible are they and how close are they to make it realistic to go and land on them?
Yeah. So if I can throw in just a tiny bit of rocket science here, it's not how far they are, it's how much speed you need to get there. So that's known as delta V, because everything's moving around in a circle around the sun anyway. Depending on how it's moving, sometimes they come closer, sometimes they come further away. So you're completely correct in that there's millions of them, but a lot of them are in the main asteroid belt out beyond Mars. And they're just a little bit far. Naturally, the closer they are and the more accessible they are, the cheaper it will be to send stuff there and bring stuff back. So what we're looking at is the NEAs, near Earth asteroids. Name implies they come close to Earth. In terms of accessibility, some of them are actually more accessible than the moon in terms of total delta V for a round trip. Again, you have this benefit of, because they have such low gravity, when you get there, taking off from them, even with a big chunk of mass to bring back, doesn't actually require much fuel.
And the burn up, so is it feasible to bring it back to Earth? How do you control the entry and the no burn off?
Yeah. So there's a few schools that, as you mentioned yourself, there's the use it in space or bring it back down to Earth. The use it in space, there's no burn off because you're not bringing it down. On the way down, Elon's Starship, rather the SpaceX Starship, it can loft 100 tons to orbit. Given a small refuel on orbit, it can bring down a similar amount. It's also got a fairing that's about 9 meters across. So just for reference, say if you wanted to bring back 20 tons of platinum group metals, so about half a billion pounds worth. For that, that's only 20 tons, only 2 meters cubed. So quite massive, not very much in the way of volume. So the easiest way to bring it down would be to put it in a rocket.
Yeah, right. And I think this is where it comes back to your session, the economics of space mining versus terrestrial mining, and doing the maths on this, doing the business case. Obviously, there is one, right? Otherwise, you wouldn't have been around for 8 years. So you've done the maths, and there is a business case here. How profitable do you think this could be? Or this is just, again, the roadmap goes to 2035 plus. This is a long play for the company.
Yeah. So, I mean, I guess let me start with the economic opportunity and then get into the numbers. Right now on Earth, for just platinum alone, we mine somewhere between 180 and 220 tons per year. Mostly Bushveld Igneous Complex in South Africa, a few other sources. I believe Australia has some as well. Of that 200 tons, for comparison, 1 kilometer diameter asteroid of the metallic type with an upper 90th percentile platinum content, you're looking at 117,000 tons of platinum, just platinum. That's excluding the other platinum group metals. So that comes out to 688 years of global supply of platinum in one comparatively small asteroid. Right. From an analysis of the NEA composition, so the ones that actually come close to us, there should be at least 6 of those, statistically speaking. So that's a lot of platinum.
Yeah, okay. Well, I'm just thinking then you basically destroy the platinum industry on Earth, right? And then you've got all the platinum you need.
Well, I mean, you could say that. At the same time, you have scalable sources of demand for it. The key one there is actually the hydrogen industry. So at the moment, the first ever hydrogen car that was built by the Japanese, just the platinum alone in the hydrogen fuel cell used as the catalyst cost about 40 grand. If you want to actually hydrogenize any of these industries, for example, like some of the hard to electrify ones, like making cement, for example, you're going to need a lot of platinum. So it's also, right now, there's a lot of use cases we're not using it for. Like aluminium used to be the most expensive metal in the world back in the day. Napoleon III used it for cutlery because when everyone else used gold and silver. If you told them now that we would make disposable drinks cans out of it, they'd call you absolutely nuts. And yet here we are.
Yeah. Look, I think the idea here is to keep the audience wanting more and to attend your session in Perth. It's a fascinating field. I've got about 300 million other questions to go. And just the science, the economics, and as you say, you've become a robotics company as well, and just solving the problem that this concept, I suppose, creates in terms of the thinking involved. It's a fascinating field. It's asteroidminingcorporation.co.uk. The roadmap there. Where are you on the roadmap? You've got the scarce commercialization research applications done. I take it, and then you're working on industrial applications up to 2025. Is that where you're currently focused?
That's correct, yeah. We're commercializing our climbing robots for industrial inspection at the moment.
Okay, wonderful. Well, look, Andrey Lopantsev, Chief Strategy Officer with the Asteroid Mining Corporation. You're going to be at IPSEC the 26th of November in Perth. The economics of space mining versus terrestrial mining, a comparative analysis. Very much looking forward to meeting you, Andrey, and thanks very much for joining us on Australia in Space TV.
Brilliant, Chris. Looking forward to it.